Hello students, I, Mrs. Madhavi Mhatre, welcome you all in the next lecture of Mathematics 1. I hope all of you are doing well at home. Today only I got the information about the reduction in syllabus. Okay, so very soon I will be preparing a video which will give you the idea about the reduction in syllabus of Mathematics 1. Whatever we have studied previously, in that also some part is deducted. So you will note down that, and that part will not be asked for evaluation in your second online assessment. Okay. So in the next lecture I will discuss about the reduction in syllabus so that you will get better idea about your studies, that which sums are to be studied and which are not to be studied. Okay. Now let us start with our second chapter, real numbers. Okay. So in the previous two lectures we have discussed about rational numbers. Okay. In that we have discussed the properties of rational numbers. Then we have seen how to express rational numbers in decimal form. And then that decimal form can be of two types. Either it is terminating one or it is non-terminating recurring one. That means the division is never ending, but certain set of number is repeated again and again. Means what? It is recurring again and again. So that is called as what? Non-terminating recurring type. Then we have studied how to express these non-terminating recurring decimal fractions in P upon Q form. And then we have studied practice set 2.1 based on the properties of rational numbers. Now we are going to learn about properties of irrational numbers. Irrational numbers you have studied in 8th standard. So you have idea about irrational numbers. What we can say in short is the numbers which are not rational, they are called as irrational numbers. Okay. So now let us learn about irrational numbers. Okay. So here we will take some examples and we will take help of number line to understand what irrational numbers and whether we can show irrational numbers on number line or not. Okay, can we represent them on number line? So here you know the numbers like root 2 and root 3. These numbers are called as irrational numbers. These numbers are not rational, but they are irrational numbers. Why? You know that 2 is not a perfect square. 1 square is 1, 2 square is 4. So if we write root 4, then we can write that root 4 is equal to 2, which is rational. But here square root of 2 is not a natural number, or it is not a whole number, or not an integer also. So what we can say here is this one is irrational number. So these numbers we can show on number line, but they are not rational. So they are called as what? Irrational number. Now let us take help of number line to understand it better. So here you can see the number line, and on this number line you can see some rational numbers, you can see some irrational numbers. So this is origin denoted by capital O, which gives us 0. Okay. Then on right hand side here you can see all positive numbers, and on left hand side you can see all negative numbers. So at certain distance, some distance is taken which is considered as 1 unit, and here you can see this one is 1. After that this is 2, this is 3. So these points are giving us 1, 2 and 3. Here similarly at the same distance we can locate -1. We have seen properties of rational numbers. There what we have seen is for every rational number a there exists -a. So similarly here for 1 we have -1 on left hand side. So their opposite to each other. They are called as opposite numbers of each other. And here 1 minus 1 we get 0. Similarly, this one you can see this is minus 2, this is minus 3. So at equal distance all these points are plotted by taken a certain distance as 1 unit. Now, so here we have 1 and here we have 2. You know that 1 square is 1 and 2 square is 4. So in between that 1 and 4 we have 2 and we have 3 which are not perfect squares. So the square root of 2 we can write as root 2 and square root of 3 we can write as root 3. So this means that root 2 and root 3 they lie between 1 and 2. Correct? Similarly, as we are having minus 1 which is opposite of 1, we have minus root 2 which is opposite of root 2. Please take a note that this minus sign is outside this root sign. Okay, it is not inside. You cannot write it inside. You are wrong then. You will understand it better when we will go ahead. That why we cannot write this minus sign inside. This minus sign should be outside the root sign. So for plus root 2, we have here minus root 2. For plus root 3, we have minus root 3. Okay, so in this way, we can show the irrational numbers on the number line. So what we can say in short is, here on the number line, we can express all the rational numbers, we can express all the irrational numbers. And together, they are called as real numbers. Okay. So every real number can be represented on number line as a point, and every point on this number line gives us a real number. Okay, this we have to keep in mind. So what you have to keep in mind in nutshell that we can express the real numbers on number line. We can represent them on the number line. So they may be rational, they may be irrational. Now see how this root 2 is shown here on the number line. For this you need to do the construction. So such questions we have in practice set. That time we are going to see it better. But now I am explaining in short how this root 2 is shown here and how root 3 is shown here. So see, from here O to A the distance is 1 unit. And at the same distance from here the arc is drawn. You can see this arc. That means if OA is 1 unit, this distance, suppose this is point B here, if we have taken, not B, take any other point, say X. So here AX is also 1 unit. This is 1 unit and this is 1 unit and this is right angle triangle. Here the angle made is 90 degrees. And then you know the Pythagoras theorem, that in Pythagoras theorem, here diagonal square is equal to sum of squares of other two sides, or you can say hypotenuse square is sum of squares of other two sides. So here 1 square is 1, here also 1 square is 1. So 1 plus 1, 2. And square root of 2 is root 2. That means the length of this hypotenuse is root 2. And then by using the protractor here, okay, this one angle is first measured, and then you have to take compass, and by using the compass you have to draw the arc like this. You have studied in geometry that the radii of same circle are always equal in length. That means see, from here to here if the distance is root 2, then from here to here also the distance has to be root 2. So in this way we can locate it. So this is just to explain. We are going to do the construction actually because such sums we are having in practice set. Okay. So don't take tension now if you have not understood this. I am going to show you how to construct it. Got it? This is only to explain what are rational numbers and what are irrational numbers. Like you can see here 1 and minus 1 they are rational. Opposite to that root 2 or minus root 2, they are irrational numbers. In short, we can say that all the rational numbers and irrational numbers, they can be expressed on the number line. They can be represented on the number line by using a point, or in other words, we can say that every point on the number line gives us a certain or specific real number. Okay. So now whatever numbers we are going to study here in algebra, they are real. Okay. Now let us study more about irrational numbers. Just now we have seen that root 2 is irrational number. So why this root 2 is irrational? Why it is not rational? So let us see about that. Okay. So now we will see the relationship between irrational numbers and real numbers. So for that purpose, we will take example of root 2. Root 2 is irrational number and we have to prove this. This proof is given in your textbook. You can see this proof in textbook. So there is no need to write it. Only try to understand. Here, also when Faris sir might have taught you in geometry that when basic concepts are taught, that time you have heard about the word theorem. And then those theorems we can prove. We can write a proof for the theorem, and those proofs are of two types. First type is direct proof, okay, and second is indirect proof. So for this here we are going to use indirect proof. What is meaning of indirect proof? So here we are going to assume the given thing as wrong. Okay, that means we will assume that root 2 is not an irrational number. So we are going to assume it wrong, and finally we are going to get some contradiction. So we can say that our assumption was wrong, and then whatever given is true. So such proofs are called as what? Indirect proofs or indirect proofs. So here we are going to show it now. As I have said, you can see in your textbook and you can understand it. So we are going to say that root 2 is not an irrational number. So what we will write is that if it is not an irrational number, that means it's rational number. So we will assume that root 2 is rational. And rational number we can express in P upon Q form. So here root 2 we can express in P upon Q form. Now P upon Q is the reduced form. So this means that P and Q, they don't have a common factor other than 1. Take an example. Suppose we have 6 upon 9. So 6 upon 9 is not a reduced form. We can divide 6 and 9 by 3 and then we are going to get 2 and 3. So 2 upon 3 is a rational number where we don't have a common factor other than 1. Okay, so this gives us the reduced form where here you can say that P and Q, they are co-primes. You know the word co-prime. They don't have the factor in common other than 1. Okay. So that we are going to write as a statement that P upon Q is a reduced form of a rational number, and therefore P and Q don't have, or they have no common factor other than 1. Okay, so this is important point to be noted. And here only we are going to get contradiction because we have assumed something wrong. Okay. So now since this root 2 is rational, we can write it in this form P upon Q. So what we will write down? Therefore root 2 is equal to P upon Q. Correct? So this is our left hand side and this is our right hand side. Now let us see how to prove it. Here now let us square these two sides. Okay, let us square the sides. So what we will get here? Root 2 square is 2. And here P upon Q, if we square, we will get P square upon Q square. Okay, so we have squared both the sides. Now in the next step we will go for cross multiplication. So what we will get? p square is equal to 2q square. See, this q square is multiplied here. So p square is equal to 2q square. Now here you have studied about the definition of even numbers. You know that 2, 4, 6, 8, 10 and so on, they are even numbers. Also in the chapter set, when we wrote the set by using set builder form, there we wrote that every irrational number can be written as the multiple of 2. Okay, every even number can be written as the multiple of 2. So here we have got here multiple of 2. 2 into something is there. That means we can say that p square is multiple of 2. So we can say that p square is even. Okay. Now since p square is even, p has to be even. Because we have studied this also, that square of even number is even. Therefore, we can say that p square, if it is even, then p is also even. You can recall the squares. In the beginning, in the very first chapter, I told you to write down the squares. 1 square, 1. 1 is odd, square also odd. 2 square, 4. 2 is even, 4 is square, which is also even. So, square of even number is even. Therefore, we can say that square root of even number is also even. So, if p square is even, then we can say that p is also even. Okay, so what we can say is p is also even, means 2 is a factor of p. Number this as 1. This is our first statement. See what we have said in the beginning, p and q don't have any common factor. Okay, so for p I have found out 2 as a factor. Now let us see what happens with q. Since p is even, 2 is a factor of p. Now let's go further. So this p we can express in the form of 2 into any other number. Okay. So this p I can write as 2 into t. T I have taken as some other number. T is my one more number. T belongs to integer. It can be plus, it can be minus. But p I can express in the form of 2 into something. Why? Because it is even. You know that even number means multiple of 2. So for this I have taken any other letter. Instead of taking number, any other letter is taken. Again we are squaring both the sides. So here what we got, p square, and here we got 4t square. Okay. But just recall what we got previously. P square is equal to 2q square. So in place of this p square, we can write 2q square. See, previously we have got this. P square is equal to 2q square. Therefore, this p square on the left hand side is replaced by 2q square. And right hand side is kept as it is. Okay. Now we can divide by 2 on both the sides. And then we will get q square is equal to 2t square. See, like previously we got for p square is equal to 2q square. We got for q square as 2t square. So what we can say now here, since q square is multiple of 2, we can say that q square is even and therefore q is even. Okay, immediately we can write down the same statements. So once again, if q is even, so what we can write, 2 is a factor of q. Okay, so for p we got 2 as a factor. Also for q we got 2 as a factor. But what we stated in the beginning, that p and q, they don't have the common factor other than 1. But here we got 2 as a common factor. Okay, so this is contradictory to what we have seen in the beginning. Okay, so from 1 and 2 we can say that 2 is common factor of p and q both. And this is contradictory because in the beginning we assumed that p and q don't have common factors other than 1 or except 1. So why this contradiction arised? This is because of our wrong assumption. We assumed that root 2 is rational. So that was our wrong assumption. So we can say that our assumption was wrong. Okay. So what we can write is our assumption that root 2 is rational is wrong, and therefore we can say that root 2 is an irrational number. Similarly, we can prove that root 3 is also irrational, root 5 is also irrational, root 7 is also irrational. So numbers which are not perfect square, if they appear under root, then they all are irrational. But here, if perfect squares they appear, then they are not irrational. Like square root of 4, we can write that it is 2. It is not irrational, it is rational. So that you have to keep in mind. Okay. So similarly, we can prove that all these numbers are irrational numbers. Now these numbers we can show on number line. As I have said that in exercise we have question how to show them on number line. So that time we are going to see that construction. Okay. Now let us go further. So as I have said, or as I have discussed previously, that here that every point on the number line gives us a rational number or it can give us a irrational number. So the numbers which we are showing by point on the number line, they all are real numbers, and therefore we can say that every point on the number line is associated with a unique real number, and here every real number can be represented on number line. Okay. So here these are the two statements which already I have explained you with the help of number line. Okay. So these are given as the important points in your textbook, that every point on a number line is associated with a unique real number, and opposite to that or converse to that is what? Every real number is associated with a unique point on the number line, as we have seen different points there. Okay. Now let us go further. Now here we have studied about only root 2. Now let us think about the addition of a rational number and irrational number, whether they are rational or irrational. Similarly, we will see for multiplication, we will see for division. Okay. So let's go further. Now here about irrational number, one more important information, that what is the decimal form of irrational numbers. Okay. We have seen previously in practice set 2.1 that whenever we want to express the given fractions by using decimal form, we divide actually. Okay. But here division will not help us. Here if we want to find out the square root of 2, then this division method is used. Division method of finding square root. It's not actually the division which we are doing regularly. It is different type of division. So this is division method, not division. This you have done in 8th standard. Division method you have used in 8th standard. So you know that for this division method, you are making the groups of two digits. And grouping you are starting by using this decimal point. So groups are made accordingly. So here in normal division we are taking one number down, but here we are going to take 2 digits simultaneously. Okay. So like here division is done for 2. Since you have studied this, I am not explaining the method. So square root of 2 we can write as 1.41421 and so on. Now this division method if we use, it is never ending. It is not going to end. It is going to continue. That is why here the answer which we are getting is non-terminating one, also non-recurring one. This is never ending. It is not going to end. That is why dot is put here. You can observe both the places for square root of 2 also and square root of 3 also. When we have seen the division previously, what we saw is either it is terminating or it is non-terminating recurring type. But here both the things are not possible. It is not terminating, and non-recurring type also. It is never ending. It is non-terminating we can say, and never ending. Okay, so this is only for your information that decimal form of irrational numbers is non-terminating and non-recurring. This you have to keep in mind. Okay, forget about this. Nobody is going to ask you this method. Only keep in mind that the decimal form of irrational number is non-terminating, non-recurring. That's it. Okay. Now let us go further to see whether the addition of rational and irrational numbers is rational or irrational. So we will take example 2 plus root 3. See, 2 is rational number and root 3 is irrational number. So this addition of rational and irrational, is it irrational or it is rational? So here also we are going to use indirect proof. That means we are going to assume that it is not irrational. That means it's rational. And then we are going to get contradiction. Okay. So let us assume that 2 plus root 3 is not an irrational number. That means it is a rational number and therefore we can express it in the form of P upon Q, which is the reduced form as I have explained. P and Q are co-primes. They don't have a common factor other than 1. So since 2 plus root 3 is rational, which we have assumed, we can write down 2 plus root 3 as P upon Q. Now what we are going to do is this 2 we will shift on right hand side. So we will get root 3 is equal to P upon Q minus 2. Okay, now P upon Q is rational number and 2 is also rational number. So their subtraction has to be rational. So here this right hand side, it is rational. And observe the left hand side. We have already proved that root 3 is an irrational number. So here what we got, right hand side is rational and left hand side is irrational, which is not possible. You know that for equation both the sides has to be equal. But here what we got, one side is rational and other side is irrational. So that you have to write down that here we can say that left hand side is an irrational number and right side is a rational number. So which is contradictory. It is not possible. And that why this contradiction arises? Because of our wrong assumption. What we assumed is 2 plus root 3 is not irrational. That means it is rational. So our assumption was wrong. And because of that wrong assumption, we got contradiction. And therefore what we can say is that this 2 plus root 3 is not a rational number, but it is an irrational number. Okay, so what we can say is addition of a rational number and an irrational number is an irrational number. So if we add one rational number and one irrational number, we are going to get irrational number. Similarly, we can prove for multiplication. Okay, if we multiply 2 into root 3, we are going to get 2 root 3. So we can prove that this 2 root 3 is an irrational number. Okay, so here the proof will have the same steps. Okay, but they are not proved in the textbook. Directly they have written that. Similarly, we can prove that 2 root 3 is irrational. So addition of a rational number and an irrational number is irrational number. Similarly, multiplication of a rational number and an irrational number is irrational number. Okay, so this you have to keep in mind. Let us go further. So just now I told that the multiplication of rational and irrational is irrational. Now let us think about two irrational numbers. Their addition, their subtraction, their multiplication, their division. So here you can see that 2 plus root 3 is irrational number. This minus root 3 is also irrational number. And if we add them, see here plus root 3 and minus root 3 gets cancelled and we get 2, which is a rational number. Okay. So here we can say that addition of two irrational numbers, it is not irrational always. It can be rational also. Okay, so you have to keep this in mind that addition of one rational and one irrational is irrational. But addition of two irrational numbers may be rational or may be irrational. It is not compulsory that it's an irrational number. We have proved this. Okay. Let us see more examples about multiplication and division and subtraction. So, second example now. See, 4 root 5 divided by root 5. So, when we divide here, root 5 and root 5 will get cancelled and we got 4, which is a rational number. Okay, so 4 root 5 was irrational, root 5 also was irrational. So, division of these two irrational numbers is a rational number. Okay, so this you have to keep in mind. Let's see more examples. I am displaying all. So, see here now. This is also one irrational number. This is irrational number. Subtraction is done. Minus sign shows subtraction. So, here also root 5 will get cancelled and here we got 3. Similarly, this is example of multiplication. 2 root 3 irrational and root 3 is also irrational, but their multiplication is 6, which is rational. Okay, so in these all 4 cases, see, one is example of addition, one is of subtraction, one is of division, one is of multiplication. So here division or multiplication or addition or subtraction of two irrational numbers may be a rational number. Okay, it is not everywhere true. So you can see these examples now. Root 2 is irrational and root 5 is also irrational and its product root 10 also irrational. Okay, so here you can see this product is rational but this is irrational. So both the things are possible. Similarly, this is example of subtraction now. 2 root 5 minus root 5, the answer is root 5. Like 2x minus x is x. So similarly here, now here this is irrational and the answer also is irrational. See, so these are the two different examples. So here we can see that when we perform the operations on irrational numbers, then the answer may be rational or may be irrational. Okay. So these points you need to remember. So let us see those points. So in your textbook you can see these points. Remember this. The very first point here, and which we will name them as properties of irrational numbers. Okay. So the first one which we have seen, addition or subtraction of a rational number with irrational number. One is rational and other is irrational, then the answer is going to be irrational. Same thing is valid for your multiplication also. Multiplication of one rational number and other irrational number is an irrational number. Okay. So that is the second point, that multiplication of division of two non-zero rational numbers with an irrational number is also an irrational. So one rational and other irrational, then the answer is irrational. Whether it is addition or subtraction or multiplication of or division. But this is not true in case of both the irrational numbers. That is why the third important point here, that addition, subtraction, multiplication or division of two irrational numbers can be rational or it can be irrational. Okay. So I hope you must have understood the concept of irrational numbers. As we proceed further, you will understand it better. Okay students, so today we are stopping here. All of you please go through all the points. Once again you read the textbook, try to understand the points given there. And still if you have doubts, then you can ask me. Okay students, so today we are stopping here. We will meet in next lecture. Till that, you stay home, stay safe and take care of yourself. Thank you students.